Hey guys, we are back again with yet another way that you can solve quadratics when they don't come out nicely in terms of necessarily factoring, although you can use this for everything, even if they do come out nicely for factoring. And when completing the square doesn't always work the nicest. Those are going to be the primary ones, but you can really use this for anything.
So standard form, again, is ax to the second plus bx plus c equals 0.
Our new piece is the quadratic formula, which is the subject for today.
Which states that x equals opposite of b plus or minus the square root of b to the second minus 4ac divided by 2a.
So if you can factor, factoring is a better choice because this is a lot of computation that some of you might screw up. But you, like I said, you can really use for anything. The thing you have to make sure of is it has to be in standard form. That means if anything is on the right-hand side, you need to get it all on the left-hand side so it's all together. If you have a hard time remembering this, you can hum Pop Goes the Weasel. This fits in perfectly. One thing I do stress is that please do not refer to this as negative b. It is the opposite of b. And the reason why I stress that is because most of you, I have found through my years of teaching this, if you refer to it as negative b, the moment you get a b value that's negative, you don't do anything to it because it's already negative. It needs to be the opposite. So if your b is negative, you put in a positive. So let's get started with some examples.
So step 1, identify a, b, and c.
Now, a, b, and c, remember, are not your variables. They are the numbers in front of the variables. So a here is 1, b is positive 5, and c is negative 14.
Step 2, substitute a, b, and c into the formula and simplify.
So that means we're going to use that x equals the opposite of b, so negative 5, plus or minus the square root of b squared minus 4ac all over 2a. I do expect to see this. Here's the other key. All of it is over 2a, not just the radical. Because if you do just the radical, it's going to screw with the whole problem. So now we go and start number crunching. So we have negative 5 plus or minus 25 squared is 25. And then we have minus 4 times 1 times 14, which is 56. So that's minus a negative 56 because it's minus here and we have a negative here. So, and then 2 times 1 is 2. Now we have negative 5 plus or minus 25 minus negative 56. That's plus 56. So 56 plus 25 is going to be 81 over 2. We luck out here in that 81 is a perfect square. So that means I have negative 5 plus or minus. We already have the plus or minus in there. So a squared of 81 is 9 over 2. If you can simplify this, you need to simplify this. In our case here, we have 2 separate situations. Our first one is negative 5 plus 9 over 2, and the second one is negative 5 minus 9 over 2. If we take negative 5 plus 9, that's 4 over 2, so that means we get x equals 2, so 2, 0. The second one is negative 5 minus 9, which is negative 14 over 2, which is negative 7, 0. This one, you know if it's factorable if you come out to nice numbers. You shouldn't get nice numbers with these. We gave you one to start off that was easy so you knew, because if I factor x squared plus 5x minus 14, I know multiplies to negative 14 adds to 5 would be 7 and negative 5, or sorry, 7 and negative 2, which would be x plus 7, x minus 2, which when we solve those gives us 2, 0 and negative 7, 0. Let's try the next one. Next example, here, a is negative 3, b is 9, c is 5. So we put them in. X equals the opposite of b, so negative 9 plus or minus the square root of b squared minus 4ac all over 2a. Now we start simplifying. If you see that you have a negative and a negative, you know you're going to end up with a plus, which is helpful. So now we got negative 9 plus or minus square root of 81. Negative 4 times negative 3 is positive 12, times 5 is 60, so plus 60, all over negative 6. So now we got negative 9 plus or minus the square root of 81 plus 60 is 141 over negative 6. Now, here's where you need to look. First, we need to check that 81 or that 141 is not divisible by anything. If I check 64, doesn't work. If I check 49, it doesn't work. If I check 36, it doesn't work. If I check 16, it doesn't work. If I check 9, it doesn't work. And if I check 4, it doesn't work. So I'm going to check one more. I'm going to check 81. And that one doesn't work either. So 141 is a simplified square root. Here's the catch. You cannot have negatives in the denominator. Here's the thing. If you divide, you have to divide everything. You basically have to butterfly it out. But if you butterfly out a positive negative with a negative, it's still going to be positive negative. I mean, you can get technical and say negative positive, but really it doesn't matter. Where it matters is right here. So a negative divided by a negative is going to become positive. So what you have is 9 plus or minus the square root of 141 over 6, which I know looks super ugly, but we're going to leave it because that would be our answer. If you get something like this, I'm not going to make you write that as an ordered pair, but here's what it would look like. You would have 9 plus the square root of 141 over 6, comma 0, and 9 minus the square root of 141 over 6, comma 0. So super ugly, we're not going there. So if you get something ugly, you can leave it as x equals, because I wouldn't make you graph those next unit anyway. All right, one more for you. Here, we don't have everything on the same side. So I'm going to suggest, rather than moving the 4x squared over to the right, which would make a negative 4x squared, I would rather move all of the other terms. So I'm going to subtract 8, and I'm going to add 3x. So that gives me 4x squared plus 3x minus 8 equal to 0. So now when I do my a, b, and c, I get 4, 3, negative 8. Put them in the function. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So now when we start number crunching, we get, let's scroll this up a little bit so I can, we get negative 3 plus or minus the square root of 9. I know I have plus because it's negative 4 and 8. Well, 4 times 8 is 128 over 8. So negative 3 plus or minus the square root of 137 over 8. And I'm just going to double check. 137. I know it's not divisible by 81. I know that it's not divisible by 64. I know it's not divisible by 49. It's not divisible by 36. I know it's not divisible by 25. So we'll check 16 and we'll check 9. And none of those work. And I know it's not divisible by 4 because it would have to be even. And we don't have a decimal in the or a negative in the denominator. So that would be our answer. I know, ugly, but what can you do? So now you get to try. We have these two U-try problems, one with everything on one side and one with everything kind of mixed up. Neither of them are factorable, so you do have to use the quadratic formula to do so. If you have any questions, bring with you to class, and we will see you tomorrow.